lesson 3.3.
Number 3.
Number 3. What we're going to do is use Cramer's rule to compute the solutions of the systems in this exercise. Number 3. So we have 3x1 minus 2x2 equals 7. And for our second equation, we have negative 5x1 plus 6x2 equals negative 5. So the system, what we're going to do first is take our system and set it equal to the equation AX equals B, where A equals the matrix 3, negative 5, negative 2, and 6. We get this from everything to the left of the equal sign in our equation, and B is going to come from the right side of the equal sign. So B equals the matrix 7, negative 5. Okay, so we're going to calculate A1B. A1 of B, which is equal to 7, negative 5, negative 2, and 6. We get the first half of this from B, which is 7, negative 5. We get the second half of it from the right side of our A. For A2 of B, we're going to have 3, negative 5, 7, negative 5. And we do the same thing as before, except here we have the left side of A followed by B. Now, after the calculation, we're going to have determinant. Determinant A equals 8. Determinant okay, so after we get A1B, the matrix for A1B and A2B, we're going to define the determinant. The determinant is matrix. You take the matrix, you have A, B, C, and D in your 2 by 2 matrix, and you're going to take A times D, minus B times C. So for determinant A, you have 3 times 6 minus negative 2 times negative 5, which gives us 8. For determinant A1B, we have 7 times 6, which is 45 times negative 2, which is positive 10. Gives us 32. For the last one, we have 3 times negative 5, which is negative 15, minus negative 35, which we get from 7 times negative 5. Calculate that, and we get determinant A2B equals 20. Now, for the next step, we have our equations to find x1. x1, we're going to use the equation determinant a1 of b over determinant a equals 32 over 8, which when reduced equals 4. For x2, we have determinant a2b over determinant a equals 20 over 8, which reduces down to 5 over 2. And that's our answer. x1 equals 4, x2 equals 5 over 2.